Hello and welcome to the session. Just put my slides. Perfect. So welcome to the session. Today I'm going to talk about the data behind DevSecOps. So how we can use data from various analysis we've done to help secure software supply chains and kind of some best practices we've learned through this analysis. So my name's Adam Such. I'm a solutions architect at Onsite. And I help various people to kind of secure their software supply chain and look at their process to work out what was in their software supply chain and any risks associated with it. So my background is that I've been a developer in IoT and enterprise software solutions, right through to being a product owner, so kind of managing throughout the software development lifecycle. So I like to kind of focus on where in those software development lifecycle we can automate and fix early, kind of embrace our DevOps or DevSecOps to get the information in the hands of people as early as possible to fix, in this case, our software supply chains for open source. So a bit of background around the open source I'm going to talk about today. The use of open source, I'm sure everyone knows, has been going up over time. It used to be kind of a backroom thing. Security would deny that anyone was using open source, or the CTO would have no idea that we're using open source. That was years ago. Now everyone knows and embraces open source. It's not just something developers do on their own to save time. It's fully embraced within most organizations as a critical part of software development. You're not going to realistically go and write your own cryptography libraries. You're not going to write your own web frameworks. You're going to use one of the open source tools or components available. So with that kind of embracing and expansion of open source, the number of open source components has grown massively, but also the usage has grown exponentially. So we can see here the use of the Java components coming from Maven Central, which Sonatype runs for the community, has just been growing over time. That's quite how many it's grown by. Every year it goes up by a massive amount. And we see exactly the same in the other ecosystems as well. So this is NPM, again, going up massively over time. There are many, many NPM packages, but a lot of usage as well. So it's not just more and more coming out, it's that usage shooting up all the time, which is great. And it's kind of gone to the extent that 80 to 90% of a modern application is made up of open source, so 10 to 20%. And is the open source up those things. And as I say, it's for a good reason. It's you're not going to go and rewrite cryptography from scratch. That would be a very bad idea. And things like web frameworks include a lot of information, a lot of kind of base tooling. You're going to use those straight away and trust what's been built. But not all parts are created equal. It's hard to know if you select library, is it going to go vulnerable? There are lots of updates. There are lots of kind of movement within these open source projects. They're adding in new features. Sometimes it's hard to keep up, to update, to keep up with those new features. But does that leave us vulnerable to bad kind of vulnerabilities? But equally, if we keep upgrading all the time, like is popular in NPM, just using a latest tag, we might keep up to date, but do we know what we're pulling in? Do we know who's committing and what's coming into those things if we're just continuously updating without any kind of oversight? So I'm going to talk about how we can kind of manage some of that risk and some of the approaches that are useful for kind of managing that and knowing what's good and what's bad. So a bit of context again around this, the reasons why this kind of following these issues is getting harder and harder is the kind of background of how much money there is to be made out of cybercrime. So way back in 2016, when kind of the last public information, easy to get hold of information came out, cybercrime was estimated to be worth 450, and drugs were estimated to be $435 billion. Now, this shocked me when I originally saw these stats, but it still shocks me today, that cybercrime overtook the drugs trade, because as the picture, we know that there are specific law enforcement agencies, specific groups, and all kinds of police forces and everything else dedicated to drugs. Cybercrime is gaining a lot more attention, but is kind of on the periphery. It's shocking that they're the same value overall to the economy. And it's for good reason. We can all imagine why. It's a lot less risky, it's a lot easier to do. It doesn't follow borders, so you don't have to physically be in an area to commit cybercrime. So it's a lot easier to do across borders, and therefore a lot harder to prosecute. And you can probably guess which one's the growth industry. Drugs are pretty flat, not going to increase over time, whereas cybercrime has been increasing. And yeah, we see that with the types of attacks, a number of attacks coming out, the sophistication of those attacks. We're seeing the formation of organized groups. It's not anymore those script kiddies playing around like it was back in the early days of the web. We've kind of all heard of those basic SQL injection attacks and those type of things that happen. Those still happen sometimes, but our tooling kind of picks those up much better now. But if there are organized gangs who can chain attacks and actually inject into the software supply chain or other places into the general supply chains, then it's much harder to keep up with those things and keep on top. And I'll talk about some of those particular attacks that we've seen recently. So just for a bit of context, that's how much money we're talking about, $800 per every person on the planet in terms of cybercrime, which shows the scale of the issue. The other thing I often hear when I talk about this is people saying, I have nothing of value in my application. You might not necessarily be running a bank and obviously have cash to steal. You may not directly have money moving through your systems. You may not be an online web kind of store or something like that with obvious credit card numbers or public information that is of value. But things like CPU cycles being attacked, visitors, building infra, because cryptocurrency, they can go and mine cryptocurrency on your systems. So it's not just your valuable information, it's actually just your infrastructure they can go after now, which is a massive change from where we were years ago. Who could have imagined just your servers being useful apart from some kind of botnet, which is pretty basic. Again, more script kiddies most of the time. We're now looking at proper monetization of your AWS instances or your own servers, or even your visitors. So actually taking over your kind of web scripts to mine on your visitors. So it's completely changed the world. One example of this is Jenkins has been taken over. So lots of people had public Jenkins. There was a vulnerability within Jenkins. It was a basic library hidden in Jenkins. I think it was a transitive dependency. It was Commons Collection, had a known vulnerability. At that point, Commons Collections was a pretty old component. It's now about 14 years old, and this is back in 2018. It had an update. There was a newer version of Commons Collection that was fixed. But much like many projects, Jenkins didn't update immediately, or more accurately, they updated Jenkins, but lots of users didn't update Jenkins. I know we're most guilty of this. I've rarely update my Jenkins that I run. So just by not being up to date, people were at risk of this remote code execution attack. And people didn't use this for any kind of going in and taking over the builds, like the more modern attacks we've seen. They were actually just using this to go and mine, because they could easily do searches to find public Jenkins servers and automate those attacks to the point that they had taken over enough Jenkins build systems to mine $3.4 million up until it was kind of publicly well known. People started to upgrade and close down this attack. I'm sure they got even more after that, because there's still many vulnerable today, but that was the point we measured to. Jenkins servers, often big servers, often not running builds at night, or not many builds at night. So you can imagine how this mining happens, and you get a lot of mining done very quickly, basically for free for the attacker. We've also seen various, say, these are evolving over time. These aren't basic attacks just looking at single things. These are actually going all our flaws within the ecosystems. So the kind of shocking one back in 2014, people were accidentally publishing their NPM credentials, accidentally pushing them up to various public sources. It's very easy to do. They sit within your developer environment. So keeping those within the same area as your code, pushing them up is very easy. We've all kind of forgotten to add to our gitignore file. So those are getting pushed up, but the scale of that was shocking. And then there's been the beginning of the typo squatting attacks, and these have re-emerged over time in various ways. But these are just basic kind of ways of catching developers. So it's easy to just mistype a library or mistyping code all the time, but mistyping the name of libraries, often they're quite obscure names. It's very easy to add an S onto a name or accidentally forget a certain character within those names, and you could easily be attacked by something that looks like what you expected. You accidentally type in the name wrong, it pulls in the dependency, it works as you expect, but it includes malicious code because it's this typo squatting attack. And we've seen those in PyPy, but then they've re-emerged in things like Ruby and NPM many times. And then there was this NPM blog, which gained a lot of attention. I remember when this happened, customers I was helping at the time messaging me saying, am I subject to these exploits? Can I tell if they're within? None of these were real. These were all made up by the author of this blog. You just kind of did it as a proof of concept to show what could happen if you had bad packages in NPM. Highlighted some of the limited protection within the ecosystem, but they weren't real. But people saw them, and it raised awareness and caused some changes within the NPM ecosystem. And then one close to my heart, as a previous Go developer, I used to develop Go, work within the packages, been using Go a long time, right from the early days. And I always loved the fact that it basically used GitHub for all of your dependencies. So you could go into GitHub, see the various packages you were using, go direct to the source and pull them in. It made it very easy as a developer, but everyone became quite aware of what that meant in terms of security and awareness of the supply chain when this Go data bind got deleted. So essentially, the original developer got fed up on a Friday. They had many pull requests, people asking for new features. People weren't being good open source citizens. So they just decided to give up on the project. They decided to delete it. And that meant that remained entirely open on GitHub for someone else to come and take over that namespace, add into GitHub. And they could have easily added in something that looked the same as Go data bind, a kind of trusted package that people were using, but it then had a brand new author that could have done anything with it, added in malicious code. Luckily, that didn't happen. someone else who was running their builds on a Friday afternoon and found that builds failed because it disappeared. Just put the same code up and all was well, but it was just the luck that it was that person that took it over rather than someone else. And that caused a massive change in the Go ecosystem. We now have Go mod, and it tracks the hashes of the particular commits and all those type of things, so we can ensure that what you are pulling from GitHub is what you expect, and those versions and ranges have not changed. But an interesting case. Right through to deliberately vulnerable things like Python, stealing private SSH keys, so directly going after stuff you might have in your build environment or your developer environment. In similar way, ESLint scope hijacked to steal the NPM token. So again, looking at your developer environment. Up to, as I say, these kind of chained attacks. So this was probably the first really sophisticated supply chain attack we saw on Copay. So this was a particular NPM package, and someone kind of came in looking like a good open source contributor, made a addition to the code, added in some real improvements, but then it was fine. It was a good dependency, but then they added in a dependency, a transitive dependency that made it malicious. And this was specifically going after Copay. So they had some knowledge of the organization. They were only going after accounts that had more than 100 Bitcoin. So they knew about the infrastructure. It was targeted at Copay directly. So very interesting case. They saw their exploit work, and then they rolled back those changes to remove that transitive dependency. So case up to end, we're kind of rolling through back full circle, back to typo squatting again. So these things just keep happening over time, and we need to be aware of them. Now, a more recent case was dependency confusion. I'm sure most people have heard of this. It's been in the news, lots of people talk about it. If you haven't heard of it, essentially what happens is it relies on the ecosystems not checking the namespace of the components that are coming in. So it can, if the entire infrastructure, it can reach out the building ecosystems will firstly look internal for your internal components, but then it will also check for versions outside. Now, this was rarely seen until this attack was identified, because if you're just using an internal library, you'd use your own internal namespace, and then it of course wouldn't exist outside, but people wouldn't expect it to go and look at the external infrastructure, the places that or PyPy for those things, because it's purely internal, but actually it was. So if there was a higher version in the public ecosystems, it would reach out and grab that over and above your internal. And we saw this kind of back in July 2020. We picked up research, using pack, kind of test this out. So trying to pick up various people that had public back bounties, organizations that had public back bounties, and was going after them, and in many cases kept posting those research packages over time, and then released a blog kind of publicly talking about this. And he managed to hit Apple and Microsoft and quite a few other places, some other big names, big tech companies, because of the way that this build infrastructure worked. And yeah, we now see, since this came out, a massive rise over the time of copycat exploits happening. So people trying this and actually making them malicious. Obviously, this was security research going for bug bounties, nothing actually malicious within that. You were just making calls back to a server so it could identify when it had been run in a clever way using DNS to make sure it got out. But copy, just getting the information out to know who had been calling these packages and getting them to run on their build environments. These current ones are often real vulnerabilities. They're not just research. Another recent attack was the CodeCov attack. So I'm sure many of us have known for years that running bash scripts probably isn't best practice, but I don't know about you, but I did it yesterday to do an install. Someone went after CodeCov and modified their bash script to do an install essentially. So this was a flawed Docker image that gave them access to go and modify this bash uploader. And essentially over time, many people have been exposed, and this was, again, directly going after developers and their tooling. So when they try and install this CodeCov package to check the coverage of their testing, it was modified to call back and install vulnerable stuff, and it's hit hundreds of people. And HashiCorp was the latest to say that they had been exposed through this particular vulnerability. So this is kind of our latest in a long line of going after developers and their tooling. Going back to kind of open source components, just to call out one of many, but probably one of the most well-known was Equifax. They were using Struts 2. There was a vulnerability in Struts 2, and it got exploited, and they stole a lot of information. So yeah, it affected millions of consumers, stealing sensitive information. Many other organizations were kind of hit by the Struts 2 vulnerability, but it was just unfortunate that Equifax, they managed to get this data. Obviously, Equifax's data is very important, but others were kind of taken down, their data kind of just hidden. But this was tracked back to the Chinese military. So this is kind of, as I was speaking about earlier, back to the kind of organized nature that we're seeing. So it's not just these basic script kiddies, it's gone to kind of more organized, cleverer criminals, right through to these big groups. So this is kind of the Chinese military were blamed for the Equifax kind of theft. Then we've obviously had SolarWinds very recently, again, tracked back to government kind of backed organizations. So in that case, Russia. But also the most interesting one is North Korea. It's now estimated that the majority of their money, because of the sanctions and everything else, is actually coming from things like cybercrime. They've kind of taken this on and are making a lot of money out of it, going after particular organizations. So it's very organized, and that's how their sophistication keeps going up. And the sophistication of our apps also keeps going up as well. It's kind of been a joke for a while about NPM, about how many dependencies get pulled in, but it's for good reason. NPM does a very good job of creating small snippets of functionality. That's why there's so many packages. That's why that download count I showed right at the beginning is so big. It's nice to just be able to have those small snippets of functionality and pull them in, but this kind of has the downside of something that seems quite small, like a number is not a number package. You would think that was quite simple, and probably would be simple in some other kind of ecosystems. A C package, it would probably stand alone. But within the JavaScript ecosystem, this has like 100 odd dependencies underneath it. So these transitive dependencies can be very complex. Now, trying to manage this manually, just when you decide you need a simple snippet of functionality to add to your application, you would pull in a package. Going and actually auditing every part of this entire chain is not possible. You probably would end up just not using the package. So we need automation. Now, there's the inevitable jokes about NPM, as I said. There's many of these around, but these are some of my favorites. and our package.json. But as we get more complex and people get more sophisticated, it means our time to respond gets lower. Now, I speak to lots of organizations about how quickly they respond. So when they find a 0 day, when they are looking at their packages or looking at their vulnerabilities, wherever they come from, what do? And typically I hear somewhere around the 30 days, they get a CVE, come in, comes through security, gets raised through tooling, and there is 30 days to respond. Lots of organizations now reduce this down, and it's kind of 10 to 5 days is often a good response. Kind of more DevOpsy organizations will kind of embrace that. But if you're only releasing monthly, if you kind of only, it doesn't matter how quickly you fix, if you don't push that out until the month's up, that's kind of, it doesn't really matter how quickly you fix, it's how quickly it gets out to production. So back in like 2006, people used to talk about 45 days, and then it went down to kind of 2007, 30 days. And then it kind of hovered around there for quite a while. These are different estimates by different organizations. I said it like Gartner and IBM. And they've kind of estimated it all over the place. But the reality is Equifax were breached within days. We often now see from a vulnerability, a 0 day vulnerability, you'll see proof of concept code appearing on GitHub publicly within days, if not hours. So if someone unsophisticated, it's not to say they're not good developers, but they're people just publicly posting to GitHub, just kind of out of interest, or their security researchers showing proof of concept code, you can imagine sophisticated attackers would be getting that code very quickly and using it and searching out people who are vulnerable almost immediately, probably fully embracing DevOps and going on very quick releases. So it's imperative that we react quickly and get those fixes out quickly. Kind of waiting 30 days to put out a fix just doesn't cut it. We could easily be breached much, much quicker. So focusing on our supply chains is important. So I mentioned supply chains quite a few times, and I know people are more and more using these terms when they think about software, but where does this come from? So we kind of look back to manufacturing, because if you think about it, manufacturing's been doing these things a long time. There's a lot of kind of synergy, which we'll talk about in a moment. But a lot of this came from Edward Deming, and this was kind of back in the 40s and 50s. He transformed Toyota's manufacturing processes to make them much more efficient. It is easy to see how kind of manufacturing has transformed and is now kind of completely automated and tracked through the principles that he created. And there's a lot of synergy, as I say, between the different kind of manufacturing processes. And most of us can picture these manufacturing processes for cars, even if we haven't worked in a car plant or don't work for a manufacturing company. We all kind of know what this means. Obviously, manufacturers taking parts. If this is cars, in my example, this would be whatever it is, turbos, and leather for the seats, and all those parts. They get sent into warehouses, tracked through. They have barcodes and scanning and databases and all those parts that we can completely imagine. All of us have ordered for Amazon and know they can track those parts and see the barcodes on there. And then it goes through to manufacturing. So obviously assembling those parts. And obviously the key here is knowing which parts go through which places into which end product. And when we have the end product, being able to say exactly what came from where, what ended up in there. Now, these are often very automated factories producing a lot of cars, but we would be shocked to know that they didn't know which parts went in which car. They obviously track this very carefully. and keep those records very meticulously. Now, this maps across to software, obviously, very easily. We have parts coming in, we have our supply chain, be that open source components, be that proprietary components we buy in, or be that our own stuff we create. And then we store that in various places, be that public places like NPM or Docker Hub, or something like a Nexus repository, or even an Artifactory. We have a place to store our external and internal components. But then as developers, we feed that in, we assemble that all together. That's imperative that we do that quickly and get the most value out of all the code. But tracking it back is important as well. So when we have our finished goods, we can know what we put in to a particular release. So to pick an example here, I went on the EU website for recall notices. Now there's quite a few on there. I'm not picking on any particular manufacturer, but you can see here within a recall notice, there is a particular defect in here, and it's just a valve spring, there's some kind of issue. But the point I am trying to make here is that there's particular models, range of models, particular years, particular VIN numbers. They can track this back to. Now imagine this in the context of software, knowing an exact spring back to exactly which model numbers. I often couldn't tell you which versions of my software I changed what in. I'd have to look back to the release notes, let alone it's knowing exactly which minute resource was in there. Yeah, something like a Spring framework. Just Spring, that would be the equivalent of a transitive dependency. So we should learn a lot from manufacturing and how they are doing this to know when we have issues, we can track them back quickly and know exactly what is affected, in this case, like the equivalent of our release versions. So how do we do this, and how do organizations typically kind of go through their process, the evolution flow of doing this? So there's multiple kind of control points within the development lifecycle. So when I talk about the development lifecycle, I'm meaning open source components coming in, getting stored to a repository as you proxy them through, be that our own Nexus repository or something else, through to a developer, they develop their code, pushing source control, through to CI, push the built artifacts into a repository, and then through to deployment and making its way to production. Firstly, you can block stuff coming in. So some of this stuff is just so bad you don't even want it. So things like your AGPL licenses, your SSPL licenses, they are just anti-commercial. You're not going to want to use them. Or things like CVSS scores of 10, all those malicious packages we were talking about earlier. You just don't want them. Those malicious packages could try and steal stuff off your developer's machine. Just block them early. But then there's a whole load of other stuff that is more complex. Something like a CVSS score of 4, you probably don't just want to block that when it comes in. You kind of want to give a developer remit to have a look, work out what type of vulnerability that is, whether they can work around it, whether it's even relevant. So you kind of want to give them visibility and feedback so they can make informed decisions about those type of things. Because if you block every vulnerability right down to CVSS scores of something like 2, they're never going to get anything. You don't want to block everything at that first stage, only the very worst stuff, but allow developers to make the right decisions. They're normally good at making those decisions. You want visibility as you commit that code in. You want to know what's happening during that build. That's your enforcement point, kind of a more corporate enforcement point. Let the developers make decisions, but then kind of enforce those policies during build. So we can do that as well. And enforce during deployment as well. So being able to block a deployment if a developer has made a wrong decision or something new has appeared in between time and go to production, because vulnerabilities appear every day. We also want to monitor for new issues. So this is kind of the best practice, I would call it, that I see talking to various organizations. So kind of, but what we typically see is people just trying to manually approve this and block everything that's bad. No, this just doesn't work. It's very hard to follow. So you need this automated. If you introduce a process that takes weeks, developers will bypass it or just stop using open source, which will slow them down. And equally, you can't just rely on penetration tests at the end. They are a useful tool, but just kind of a black box check at the end is potentially going to miss stuff and also slow you down, because you'll get all the way to the end just to tell a developer the library or framework they've been basing their entire software on is vulnerable, and they need to remove it or start again. There is no upgrade path. So letting them make that decision right at the beginning is going to save a lot of time and kind of embrace DevOps. And it's not surprising that the regulation is kind of catching up to these attacks as well. So OWASP, way back in 2014, kind of released guidance in the top 10 that you should watch out for your open source software and create bill of materials. But there's been more and more regulation over time encapsulating this. Most of this around vulnerabilities, but more recently, interestingly, and a particular area of interest for me is licensing as well. As I say, we often see things like GPL licenses. Those are just anti-commercial. Google block AGPL and SSPL licenses entirely from all software. And there's a lot of nuance to licensing, so people are becoming more and more aware of that. And there's more and more regulation, people requiring bills of materials and licensing and vulnerability information on released deliverables. So if you're supplying to people expect to have to provide these bill of materials soon. I've heard that it's likely today, Joe Biden's likely to announce that the American federal government will require bills of material for anything delivered to any government agency. So that's going to be a big step change. That's a reaction to the SolarWinds attack. So that software supply chain becoming more and more relevant. Just one example, PCI, often important to a lot of people. It specifically talks about open source components, knowing which open source components are coming in and making sure you remediate the vulnerabilities as soon as possible. So kind of back to Deming, we should emphasize the performance in the entire stream. So this is very much ahead of its time. This statement, it sounds exactly like the kind of philosophy of DevOps, of DevSecOps. We shouldn't be passing downstream. We should be fixing early, bringing ops and dev together, security and dev together, making sure we do things early and iterate. So this is kind of not a new concept, but it's important we embrace it in new ways to make sure we are fixing early, knowing what is good and what is bad, and not passing it along, because the longer we pass it along, the longer it's going to take, and the worse the things we're producing are, the harder and less likely we are to fix them. So that is kind of an overview of our supply chain. Hopefully this all makes sense in kind of where we can fit in and what we should be doing within those ecosystems, a bit of information about the kind of background to some of this. And hopefully we can all embrace this. I, within my software, anything I write now, certainly think differently. When I was back writing software a few years ago, I certainly would not have known exactly what I was using coming through to each release. I now look at it very differently, taking this into account, and we can fit this into our development life cycles. If you want to come and speak to us about this or know any more information, please come speak to us at our stand. We have a stand, and you can also go and see if your software is hackable through these open source attacks with our vulnerability scanner, or come and speak to me on the stand or one of my colleagues, and we can talk you through how these things can happen and any information. But I would love to open it up to questions now. If anyone has any questions they would prefer to put to me privately, you can reach me on Twitter or on email, but please feel free to raise
on the Q&A section within the session.
No question. No, if there's no questions, I'll close the session now. But as I say, feel free to reach out to me. I'm happy to answer questions privately, or the software supply chain generally. I'd love to talk to you. Let me know what you thought of the presentation. Thank you very much, everyone, for joining.